Good morning, my dear students, and today we are going to discuss about the transformer. Transformer is a electrical device. Now there is a question, what is the difference between electrical and electronic devices? Generally we see that in electronic devices, they will operate on certain frequencies. Means electronic devices require less amount of current, less voltage, and they work on the uh, very high frequency, like computer, calculator. These are electronic devices. They require less amount of voltage, and uh, they need a regular interval of pulse, electric pulse they need. But in case of electrical devices, they operate on high voltage, high value of current. Means when the magnitude of current and voltage is very high, then that type of known as electrical devices, like fan, electrical devices, heater, electrical devices, AC, electrical devices. But mobile phone, electronic device, calculator, electronic device, wristwatch, electronic device. Okay. Now the this is transformer. It is a electrical device. It is device. Then what will its function? It convert AC current, alternating current of low voltage, into alternating current of high voltage. Means it will convert a AC low voltage to AC high voltage, and also it convert AC high voltage into AC low voltage. When it converts low voltage into high voltage, the transformer is known as step-up transformer, and when high voltage convert into low voltage, then it will be a step-down transformer. And this is the work on the principle of mutual induction. Okay, here there are two type of transformer is there, core type and cell type. In core type transformer, uh, there are two coil, primary coil and secondary coil. The coil which is attached with the energy source, that is known as primary coil. Here this is source of alternating voltage. Therefore this coil which is attached with the alternating voltage source, means energy source, that is known as primary coil. Whereas the other end through which where we drain the current or voltage, output end, this is also known as, this is secondary coil. In same way, this is a primary coil. And cell type, the primary coil and secondary coil both are owned on the same place. Okay, but in core type, primary coil and secondary coil are owned on two different places. Okay, this is the difference. Suppose the number of turn in primary coil is Np and number of turn in secondary coil is Ns. Here number of turn in primary coil is Np and number of turn in secondary coil is Ns. EMF induced in primary coil, here EMF induced in primary coil is Ep and EMF induced in secondary coil is Ns. S for secondary. In same way, induced EMF in primary Ep and induced EMF in secondary coil Ns. Okay, we know that and current in this primary coil is Ip and current in secondary coil is Is. Here current in primary coil is Ip and current in secondary coil is Is, and number of turn is this one. Okay, we know that this EMF induced in primary coil is directly proportional to the flux, rate of change of flux. Suppose that d phi by dt is the rate of change of flux and number of turn in primary coil is Np. Therefore, we can write Ep is proportional to, or Ep is equal to, here Ep is equal to minus Np d phi by dt. According to Faraday law of electromagnetic induction, the induced EMF is equal to negative rate of change of flux. Okay, and by using same rule, induced EMF in secondary coil is equal to a rate of change of flux with time into number of turn in secondary coil. Both are owned on a same frame, therefore rate of change of flux in primary and rate of change of flux in secondary coil we can assume same, equal. Then this ratio ES, induced EMF in secondary coil upon induced EMF in primary coil, EP, is equal to NS d phi over dt is upon Np d phi over dt. So d phi by dt cancel and we get EMF in secondary coil upon EMF in primary coil is equal to number of turn in secondary coil and number of turn in primary coil. Means EMF induced is directly proportional to number of turn. And this is known as transformation ratio, small r, transformation ratio. If this r is, this r is transformation ratio, from here, if r is greater than 1 and if r is less than 1, if r is greater than 1, it implies that Es upon Ep is greater than 1, because r is greater than 1, and therefore now you can write in this way: r is greater than 1, r means Es upon Ep greater than 1, means Es is greater than Ep. Means EMF in secondary coil is more than EMF in primary coil. Means voltage across secondary coil and voltage across primary coil, this voltage across primary secondary coil is more, therefore it is a step up transformer. Step up transformer. Okay, and if this ratio is less than 1, then it is a step down transformer. Here, if R is equal to less than 1, if R is less than 1, Es upon Ep is less than 1, means Es is less than Ep, and E is proportional to number of turn in secondary coil is less than number of turn in primary coil, and from here we can write this is step down transformer, a transformer in which output voltage is less than input voltage. That transformer is known as step down transformer. Here number of turn in secondary coil is more than number of turn in primary coil. Means the side where the number of turn is more, that will be at higher potential, that will be at high potential. Okay. Now if we assume that the input and output power is same, in ideal case the power, input power and output power is same, input power P input is equal to P output. This is input and this is out, here in and this is out. Input power for this primary V into I means EP into IP is equal to ES into IS, because P is equal to V into I, power is equal to V into I, here V I, and we know that ES upon EP, ES upon EP is equal to IP upon IS is equal to transformation ratio is equal to NS upon NP, number of turn in primary to number of turn in secondary coil. This is transformation ratio. Now the different losses in transformer. The efficiency of transformer is about 98%, or okay, efficiency of transformer is about 98%. It is the highest efficient device, 98%, and this is equal to output energy input energy into 100. For ideal transformer we can assume that the efficiency is 1 or 100%, but in real practice there is no any device, no any machine having efficiency 100%, having efficiency equal to 1. There is a loss in energy. There are 5 points given here. First point, copper loss. This is the primary winding and this is secondary winding, and this coil is made up of copper, and when current flow through the copper, then heat will produce, and that heat will be equal to I square into R. Means when current flow through the coil, then it will lose energy, it will produce heat, and therefore the heat released by the transformer is given by I square into R. And we can minimize this heat loss by taking thick copper wire. Okay, if we take thick copper wire, then resistance will decrease, because R is inversely proportional to cross section area. As area increase, resistance decrease, therefore heat loss will decrease. Okay, Now, ED current loss. We know that it is based on electromagnetic induction, means when current pass through this primary coil, it will become magnet, and therefore the iron core which is inside this coil, that will also become a magnet. And if that is a solid magnet, complete magnet, then there will be chances of formation of ED current. Definitely, when the flux through a iron core change with respect to time, then that change in magnetic flux produce ED current inside the magnetic material. We can minimize the ED current effect by taking a small laminated iron core. Suppose that if we take a single thick iron core like this size, if we take this much size of thick iron core, then the chances of formation of ED current is very high here. But if we cut into small slices and paint them, means break the continuity, means laminated iron cores are taken to minimize the ED current loss. This is the formation of ED. ED current is always give negative response. Not this current is not in useful work. It causes damaging effect. And third, hysteresis loss. Hysteresis loss means when current flow in such a way that the direction of magnetic field is this one for half cycle. Next half cycle, the direction will change. This will become this side. This is iron core, therefore domain of the iron inside this iron core will rotate by this magnetic field. Suppose that domain of iron core, you can assume that a small tiny magnet, and this is the external magnetic field. Means this laminated core is filled of small magnet, atomic magnet, and according to the external field, these magnets are arranged themselves. External magnetic field apply torque on magnetic dipole, and a small magnet, atomic magnet, is a magnetic dipole, and due to this electric change in current, magnetic field is set up by the external current. Therefore, due to the influence of external magnetic field, the atomic magnet will rotate in each cycle. Therefore, during the rotation of this atomic magnet, they require some energy. Therefore, that energy is given by this current. So, the some energy is lost during hysteresis, means rotation of atomic magnet. Okay. Second, flux linkage. Flux linkage means the total number of magnetic line which pass through this primary coil will not exactly pass through the secondary coil, because here the magnetic line of force are in this direction oriented. Some will be in the air, therefore the total magnetic line which is originated from this primary coil will not enter into the secondary coil. Therefore, due to the leakage of the flux, some energy is lost, and we can prevent this energy by binding the primary or secondary coil on the same place, so that the total number of magnetic flux or flux linkage passing through the primary coil will also pass through the secondary coil. In this way, we can minimize the flux leakage. And second, humming noise. This is a humming noise. When transformer work, when it will be in forward direction, during the working of the transformer, the iron core is elongate and contract, like our. In this way, a very little elongation, and this will produce a humming sound. So the energy will loss in the form of humming noise. Okay, and thank you for today.